Hey guys, happy Friday if that's when you're watching this. So we're going to start a new unit on confidence intervals and hypothesis testing. And so today I'm going to go through the first couple notes. We're going to just go through what's a confidence interval and then do a problem. And so like on our calendar, which is from Schoology, so like gonna do some notes today. If we need to, I'll go over it on Friday, or go over on Tuesday what we're doing right now. There's a worksheet that goes with this that you're getting to, and then we'll do another note, and then to get like our third test grade in, we're gonna have like a mini test over this confidence interval stuff. And then in the next 6 weeks, we'll go into hypothesis testing, and we'll keep going from there. So we're going to do a few days of notes, a couple of assignments, and then like a small 10 question test. So I am in Schoology, Chapter 8. If you want to look at it, we're in the notes for today. Okay. So let's talk about what is a confidence interval. What is a confidence interval? So looking at this. All right. So just pulling it back from like what we just did, talking about sampling distributions. So let me talk about that. So what we did with sampling distributions is we said like they end up piling. A sampling distribution is all the possible samples of 50, like the average height from Bryan High, a sample of 50, and it's like where does it stack up? So we decided that we saw that they stack up normally. That was a beautiful drawing around the true average. So let's say this is the true average height of Bryan High, which is whatever, 5'6". I have no idea. So what a sampling distribution was a bunch of these sample means. So this is a sample of 50, this is a sample of 50, another sample of 50, another sample of 50, another one, this one, this one. So like we had a bunch of just a bunch of sample means stacked up on top of each other. And a bunch of them stacked up here in the middle, and then we had a few on the edges, kind of normally distributed. So that was a sample distribution. Sample distribution, yeah. Okay, so what is a confidence interval? So a confidence interval is kind of like if we didn't have time to do like all the possible samples. This is kind of a hypothetical thing. Like it's kind of like you can't do all possible samples of 50. So a confidence interval is like, what if I just took one sample of 50 and got their average height for Bryan High? And let's say I didn't know this information. Like I didn't know that the true average height was 5'6", and I didn't know where I was at. So let's just say I took a sample and I got an average height of those 50 people of 5'8", 5'8" inches. Okay, so like since I don't know this over here, like I don't know where the true average is. I have no idea if this sample is high, low, in the middle, like way on the edge. I have no idea where this 5'8" is. So what we're going to do is we're going to make an interval. An interval is just a range of values. So we're going to get to that, like how do we do it? But basically we're going to add plus and minus a certain distance. So we're going to do a problem together. For right now, let's just say that I added, to give myself some leeway, like some wiggle room for being wrong or right, like I got a sample of 5'8", and I think the true mean is somewhere plus or minus, I don't know, let's go like a bigger one, 3 inches. So I'm going to go anywhere from 5'5" to 5'8" plus 3 is 11. 5'11". I think anywhere in this interval, so in the interval is the average height of BHS. That's what I think. I think this. That's what I'm going to go for. I'm going to guess this. So a confidence interval is taking the sample mean, and then I plus or minus a certain distance. We're going to get to like how you do this distance. I get an interval, and then I say I think the true average height is somewhere within here. So I get a guess, which this guess is a sample mean. So I do a sample of 50 people from Bryan High, got this height. Then I plus or minus to get an interval. All right, so we're going to add, what we're going to look into here first is how I'm going to put a certain amount of confidence on this range that I'm getting. So let's look at this applet here. All right, and so looking at this applet, the main thing we're going to focus on is like the confidence that we give it, and we're going to focus on how the sample size affects it. So what does the confidence mean? And then we're going to get into, at the end here, actually doing a problem, solving for it, using our formula sheets and stuff. Okay, so right now, I've got a 95%. We give percent confidences. So let's say I have a 95% confidence level. And let's say we keep the theme of like average height of Bryan High. So I'm going to do a sample size of 15 people from Bryan High. And this is where the actual average height of Bryan High is. But I don't know that actual number. But let's just say that's where it is, whatever this is right here. So I'm going to do a sample of 15 people, and we're going to get into what this number means. So let me just do this. So let me do a sample. All right, so you can see the dots. 1, 2, 3, 4. This is 15 dots. It got this. Let me use my board. This right here, this dot is our X bar. And then what we did is we plus some number minus some number to get my range. So remember, my example was like 5'5" to 5'11". All right, so it's like this one. They got an X bar, and then they gave themselves a little range here. All right, so that was one sample. So let me just do another one here. Let me just see. So did we here? So the question is, did our interval? So here's my sample mean of 15 people, their average height, and then I gave it an interval. Did my interval capture the true average height of Bryan High? And in this case, it did. Like, our interval is inside of this. All right, let me do another sample of 15. So another sample. All right, this one, you can see another 15 dots popped up. And I got an X bar that was a little higher. So maybe this one is 5'8". And then I gave a margin of error minus and plus from here. So I have my sample mean, and then I minused and plus to get an interval. And does this interval contain the true average height of Bryan High? It does. Like, this one was much closer, this first one, but this one still is inside of this interval is the true average height. All right, let's do another one. Okay, there's another sample. Another one, let me go to like 10. So 5, 6, 7, 8, 9, 10. Okay, I've done all 10. And right now, so I got some that were high, some that were low, high, low, low. So the thing is, this is like, I don't know where the true mean of Bryan High is. I'm just getting a sample mean, giving myself a margin of error. So far, you can see we have 10 out of 10 contain the true percent hit. So we're actually at like a perfect rate right now. I got a sample mean of 5'4" and plus or minus my margin of error. All of these contain the true average height of Bryan High. All right, let's go until we miss one. I think that one closer. Oh, all right, there's one. So at this one, we did the same process. We did a sample size of 15 people. We got their average height was right here, and we did our margin of error plus or minus, but our interval didn't contain the actual true mean. So like, let me give an example. Like, let's say that this one, I'm just making up a problem, is from 5'2" to 5'5". And let's say that the true average height is 5'6". So this interval actually missed. So it's possible for our intervals to miss. This is where we get into our confidence with it. So this was an example where we got an average height. Like, let's say our average height here was 5'3.5", and then I plussed and minused a certain number. Okay, so let's get into what this confidence means, confidence level here. So I have a confidence level of 95%. Okay, so right now, we are at 13 out of 14 have been hit for a 93% hit rate. So let's just keep going. Let me do a bunch more here and see what happens. So I'm gonna keep sampling. So I'm gonna do a bunch more. I'm gonna go all the way to 50. Oops, I went past 50. Okay, look, so right now I've done a total of 60 of these confidence intervals. And you can see we're still doing the same thing, like get the average. Don't worry about we're gonna do a problem where how do you get these numbers and stuff. Right now I'm just trying to get what does an interval mean. So a confidence interval is we get a sample and then I give myself an interval to contain the true proportion. So you can see like right here we had a couple that missed. Like I had too high of samples, which can happen, but like all these hit. So right now 55 out of 60, we're at a 92% hit rate. And my confidence level is at 95%. So we're going to see the relationship between confidence level and percent hit. So let me just do a bunch more. So I'm going to sample 25 more. So you can see I'm at 85 now. So I'm going to go to like a big number. All right, so I'm at 210 of these confidence intervals made. And you can see 96% have hit. So what does a confidence level mean? Coming over to the board, what does a confidence level mean? So the level that you're confident in is saying that over many samples, what would I say? There's kind of a wrote it down over here. So over many samples, about blank percent, and in this case, we did 95. So about 95% of our intervals will get this actual true mean. So will contain or capture the actual population mean. All right, so confidence level of 95%, you can see over many trials, so over many samples, over 200 samples, we get about 95% of our intervals hit. So this one was 96%. You can see the rate, like if I keep doing more, so I'm at like 300 samples done, like the rate is staying at about 96, 95%. So I've done 1,000 of these, it's at 95. So confidence level is directly correlated to, like, over many samples we expect a ton of our intervals, a percentage of them will catch that true mean. So when you do one sample, like, it's either going to catch it or not. But this is saying, like, over many samples, we expect that this percent hit is going to be at about this confidence level. Okay, so what happens when I change the confidence level here? So focus on what happens on our graph when I change the confidence level. So I'm going to change it to go higher. So you can see I'm at a 99% confidence level. The same sample size, 99%. What happened from 95 to 99%? 95, 99, 95, 99. So you can see the interval width got bigger. So the more confident you are, so if I'm 95% confident, then I have a smaller interval. If I'm 99% confident, I have to give myself a bigger interval. So I guess I could come over here. Do my thing. So like there to there, and if I increase it, you can see it gets bigger. So there's 95, there's 99%. So to be more confident, if I increase my confidence, more of my percent hit will happen. So as I increase my confidence, more percent will hit. So you can see the percent hit here goes up. When I increase confidence, it goes down when I decrease confidence. But my margin of error and stuff changes. So there's kind of a pullback. So when my kind of a main thing looking at just right here, confidence level, if I increase my confidence, so if I increase the percent hitting, my interval has to get bigger, my width. So here's kind of an example of, like, okay, the question is, like, why would we not use this? So why not use this all the time? Yes, I know that's not grammatically correct. Okay, so why would we not use this all the time? So let me tell you that, like the weather. Tomorrow, I am guaranteeing that it will rain at an interval of 0 to 100%. Like, what does that tell you? I am 100% confident in this. But this doesn't mean anything. Like, of course there's a 0 to 100% chance. So if I'm 100% confident, it means I have to give a really big interval. So, like, the weatherman tries to be as accurate as possible, but he makes his confidence smaller. So, like, the weather people will try and give you a really small interval. There's a 40 to 50% chance of rain, and sometimes they're wrong. If they wanted to be right every time, then they would tell you there's 0 to 100% chance. All right, so increasing confidence. So you can see if I decrease my confidence, let's go down to 80% confidence. So you can see my percent hit is at about 83% of these confidence intervals actually hit the true average. And so confidence level directly correlated to how many intervals over many intervals got hit. So it's a really small interval. So if I increase my confidence back to 95 or something, the interval gets bigger. If I go to 80, it gets really small. So a super common confidence interval that statisticians use is like 90% confident, 95% confident, and like sometimes you'll see 98, 99% confident. So it just matters. So like if you're dealing with something like super serious, like you don't want to be wrong, like the coronavirus vaccine, maybe those statisticians, those scientists were using a 99% confident because they don't want to be wrong. So they gave themselves a wider interval. But like the weatherman, he really wants to be accurate, so he's going to use an 80% confidence level because he's wrong all the time. He's just trying to give you an estimate. So he gives you a really small interval. And so these are kind of used in political polls too. You can see like a margin of error. Like the latest poll showed that President Trump was at a 42% people voting for him with a margin of error of 3%. So like plus or minus 3% from that number. That's what a confidence interval is. Here's the number plus or minus a number. Okay. All right. So if I increase confidence, my interval gets bigger. If I decrease confidence, my interval gets smaller. All right. What happens when I do something to the sample size? So what if we made our sample size smaller or bigger? So right now, take note of like where our intervals are. So that's our width right now. What if I did a sample size of 5 people? So what do you notice about, I'm still at a confidence level of 95, a sample size of 5 versus a sample size of 15. So what's the difference? A sample size of 5, smaller sample size, bigger interval. If I do a big sample size, let's do a sample of 100 people, my interval is super small. So if you increase your sample size, your interval gets smaller. If you decrease your sample size, your interval gets bigger. So that's what we talked about with sampling distributions. As your sample size goes up, your variability goes down. So sample size goes up, the variability, the spread of these confidence intervals goes down. Sample size goes down, the spread goes up. All right, so let me put some main ideas on that. So main idea, let me just talk about what is a confidence interval. What is it made of? So how do you like actually make one? So confidence interval is made up, I'm going to use some words and then I'll put some symbols on it. So a confidence interval is you get a point estimate, which is just a fancy word for a sample mean or a sample proportion, like a p-hat. Like 40% of people in my sample said this. Average height of Brian High is 5'7". So you get a sample, and then you plus and minus, you give yourself a plus and minus of a margin of error. So in the next video, or in the next lesson, so we'll do this margin of error in the next lesson. So we're going to talk about that. All right, and so how do you interpret a confidence level? So what is like a confidence level? Like example, what does it mean to be 95% confident? My handwriting, writing too fast. Okay, so what does it mean if I'm like 95% confident? So what that means is like probability. If we do many samples, so over the long run, think about probability, flipping a coin. Over the long run, if I do many samples, about 95% of the intervals. So if I do many intervals, many samples and get an interval, about 95% of those intervals will contain the true population number. Okay, so over the long run, so since 95% confident. If this was 80%, it would be many samples, 80% of the intervals will contain the true population number. Okay, so confidence just means in the long run, if I did this same procedure many times, about that many times will happen. Alright, so that's what confidence level means. Alright, and then the last thing that we talked about was like our interval size. So like what happens, our interval is made by the margin of error. So like we had a point estimate plus or minus a margin of error. So plus margin of error minus margin of error. So how do you make the interval bigger or smaller? So if my confidence level, if my confidence goes up, what happens to my margin of error? So think about the video. When I increased from 95% to 99%, what happened to our interval? Our interval size went up. So if I increase my confidence, my interval, my margin of error, has to get bigger. We had to increase my margin of error if my confidence goes up. So the opposite of true. The opposite's also true. So like, I'll put parentheses. If the confidence goes down, the margin of error goes down. So if I'm 80% confident, then I get a smaller interval. All right, and then the other one was what we've talked about. What if I increase my sample size? So what if instead of doing a sample of 5 people's height, I did a sample of 100 people's height? So if I increase the sample size, the margin of error goes down. So this one works opposite. Increasing the sample size means less variability, smaller variability. So the opposite's also true. If you decrease your sample size, you increase your margin of error. Alright, so just like what's the basics of like what is margin of error, what's a confidence interval? Okay. So what's happening here? Alright, let's try and do some problems. This one's just going to talk about the same idea here. So interpret the confidence level. So a gym teacher of a large high school wants to estimate the average number. So they want to estimate the mean number of push-ups a student can do in 1 minute. He selects a random sample. So interpret the confidence level. He selects a random sample of 30 students, and he records how many push-ups they do in 1 minute. He determines that he is 90% confident that the interval from 24.1 to 28.5 captures the mean number of push-ups the student can do in 1 minute. So what does this 90% mean? So what it means is if the teacher does many intervals, many samples, about 90% of them will contain the actual number of, so the actual, what are we looking for? The actual average number of push-ups a student can do in 1 minute. So the actual mean number of push-ups of the highlights here. If we do many intervals, about 90% of them will contain what we were talking about. Alright. B, what would happen if the length of the interval was increased to 99% confidence? So what happens to the interval if we increase confidence? So what happens to the interval is that if we increase confidence, our interval also has to get bigger. So interval gets bigger. Jeez. All right, how would a 90% confidence interval based on a sample size of 200 compare to the original 90% interval? So our original was n equals 30. Our new one is now n equals 200. So what happens to our interval? So when I increased my interval size, or my sample size, my interval will be smaller. Alright, and let's skip the bias, we're fine there. So if I increase sample size, interval will be smaller. If I increase confidence, interval gets bigger. So if you want to be more confident, you have to give yourself a bigger range. But then you can increase your sample size to make your interval smaller. So if you want a really small interval, you need to